I'm Sweetheart the Clown and I love science. Well, I'm going to show you a few science concepts today using the different things that I normally do in my show. Well, would you agree that there is air all around us? Well, you find out more about air, its properties, and some stuff about sound as well in a short while. But meanwhile, before we start all the fun experiments, I'd just like to show you a little bit about centripetal force. If you were to move this really slowly like that, you will find that it's impossible for the hanky to keep spinning or the hanky to get horizontal like this. Well, I'm going to try to use centripetal force and get it to be as horizontal as possible. See how I'm spinning it faster and faster and faster and faster until it's horizontal? Well, using almost the same principle, I'm going to be spinning a plate as well. Ta-da! So using this plate over here, I'm going to just spin and spin and spin and spin and spin. And if I spin fast enough, it will be able to spin very, very quickly by itself like so. You know what just happened? Centripetal force forced the stick from the side all the way to the center because centripetal force acts from the outside in. So right now my stick is right in the middle and I am still able to spin the plate. Alright, now we're going to ask for a volunteer and check out some properties of air that we know is all around us, but of course we contain a lot of air as well. Any volunteers?
Me!
Alright, come right over.
Right.
We have two long plastic bags over here. You get one and I'll get the other. Now, if you turn your back, I need you to blow up the plastic bag as fast as you can.
Blow up?
In fact, I'll be nice enough. I'll give you a head start of 10 counts before I start.
Alright.
Alright? So, ready? Before we start, what's your name?
Justin.
Hi Justin, nice to meet you. I'm
Nice
Sweetheart
to
the
meet you.
Clown and thank you for helping me in my experiment. If you're ready,
Yes.
on the count of 3, ready? 1, 2, 3, go! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My turn to start. Yeah! And there you go. What takes you 10 counts actually took me only 2 quick grabs. Do you know what just happened?
No, I'm out of breath.
I'll tell you what just happened. Using Bernoulli's effect. Bernoulli's theorem whereby if the air molecules are traveling very, very fast, it will create a region of low pressure. So what I just did, by blowing far away but really quickly like that, I actually created a region of very low pressure. If I were to blow into it slowly like this, I would not be able to get such a big bag like that. So a region of low pressure is created when I blow really fast into the bag, and the surrounding air, which is of higher pressure, helps fill the bag just like that. Would you like to try again? Yeah, there you go. Well, isn't that exciting? We can use science to make things a lot faster and easier. That's exactly what firemen do to clear the smoke out from a burning building. They put a fan slightly outside so that the surrounding air will be able to rush in and help push the smoke back out. So Justin, thank you very much for helping me with the show. I'm going to use air with another effect. Oh, Justin, wait a while. I am going to capture and kidnap some air with the magical pump. You know what happens with this magical pump? We will suck in air, whoop, and another rubber seal will prevent the air from coming back out over this side, maybe letting some of it out. So it forces the air out through here, as you can see. As you can see right here, oh, my hair is moving, you know that there is air. Well, air can be contained in a lot of containers, and I'm just going to show you how air can be contained in something that looks like a balloon. Who am I kidding? It is a balloon. So right over here, we have a balloon, and we have enough space over here for the air to expand into. Air will always try to move into an area where it's easier for it to move into. For example, we go on an MRT train. If you go into an MRT train and it's really squeezy, a lot of people there, would you try to walk down the train to look for a region, a place with less people?
Yeah, of course.
Of course. So it's like the air molecules. If I can make it easy for the air molecules to move into one area, meaning stretch the balloon and expand it. For example, I'll just show you a really quick example. I'm expanding this area very, very quickly. I'm also stretching it a lot, stressing the balloon. Alright, now if I were to allow the air to jump right over here, it flows from a region of extreme high pressure to one that's lower and easier to slip into. Now take a deep breath and blow. You have to go harder than that. Whoa, much better. So as you can see, it has expanded into a region whereby it's a lot easier for the air to move into as opposed to right over here where it's still tight, where I did not stretch. Yeah. So now I'm just going to show you the art of origami, which is the art of folding air. We're moving air all around here. I know it's squeaky. Do you know what's the reason for the squeak? Yeah. It's very squeaky. Do you know why? This is due to the friction of my hand and the balloon. The friction between my hand and the balloon. So if my hand is slightly wet but not wet enough, it makes a lot of sound. If my finger is wet enough, it makes less sound. And that is because it has less friction when my finger is wet. So there you go. I know you don't want this saliva-laden doggy, but hey, there you go. Thank you very much for helping me with the show. Bye, Justin. Well, everyone, that is not all that you can do. There is even more that you can do with science. And in the next episode, I'll show you more experiments that you can do with lots of fun stuff in the show that I have. See you next time.